Hey second graders, Miss Harris here again. This week I want to talk to you about addition and subtraction. We have done a lot of that this year, so you guys are already experts at it, and I want to remind you of some of the strategies that you'll be using when you solve some addition and subtraction problems. Let's start off with an addition problem and talk about all the different ways that we could solve it. Now, remember my favorite word. Most of you know my favorite word. Some of you might be guessing it. No, peanut butter is my favorite food, not my favorite word. My favorite word is, yep, you're right, efficient. In math, we want to be as efficient as possible. We want to get the right answer. That's important, right? But getting there in a way that's efficient is also important. Efficient means kind of like fast, right? The fastest way we can, but still a way that's going to give us the right answer. So when we're solving addition and subtraction, different problems have different strategies that are more efficient than others. Also, different mathematicians, that's you guys, solve problems differently, and certain ways are more efficient for different mathematicians. So we're going to talk about some of those ways today. But you do need to remember that you might solve a problem different than someone else, maybe different than your brother or sister or your friend or your teacher or your mom or your dad. And that's okay, as long as you understand what's happening and it works for you. So we're going to start off with a naked problem. Yes, I said naked. You know, a naked problem means there's no words with it, right? So I'm going to start off with 357, okay? And we're going to add 285 to that, right? So there's a couple of different ways we could solve this. We know that we've learned the algorithm, so I'm going to start with that one. The algorithm means just a set of steps that we follow, right? And so to solve a problem with the algorithm, we always start, yes, in the ones. So it's helpful, right, to put a place value chart on our numbers. So I'm going to do that first. I'm going to put on, right, my ones, tens, and hundreds, and I'm going to start in the ones. Well, since I know my facts, I know that 7 plus 5 is 12, but I can't put 12 right here, right? 12 is really a stick of 10 and 2 more ones. Now I'm going to move over to the tens. 5 plus 8 is 13, but I can't forget this 10 that came over, so I have to add him on too, which makes 14 sticks of 10. I can't put 14 in my tens. 14 sticks of 10 is really 104 more tens. Now I can move over to the hundreds. 3 plus 2 is 5, but again, I have to go with this 100 up here. So 300s plus 200s plus 1 more 100 is 600. So my total is 642. Remember, I can also use a pictorial model to solve this. So I would set that up, right? And since we're adding, right, I always have to check my sign. Since we're adding, that means we're joining or combining, which means I have to put the first number and the second number. So 357, there we go, plus 285 looks like this, right? Now again, I'm always going to start in the ones, you're right. So I'm going to get a different color to help with that. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we know that once I have a group of 10, they have to move on over to the tens. So now I have 2 ones left. Now I'm going to count my tens, right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So once I have 10 sticks of 10, they have to move on over to the hundreds. 1, 2, 3, 4. That leaves me with 4 sticks of 10, which has a value of 40. Now I have to count my hundreds. 1, 2, 3, 4, 5, 6. But since they're hundreds, that's 600. 600 plus 40 plus 2 is equal to 642, right? Not the only way to solve it. I could also use expanded form, right? So down here, I'm going to do 300 plus 50 plus 7, right? 200 plus 80 plus 5, right? Now I'm going to start in the ones again. 7 plus 5 is 12. 50 plus 80. Well, 5 plus 8 is 13. And since these are tens, 50 plus 80, I can make 100, and then I would have 30 more. So 130 plus 500. Now I have to start putting some of my pieces together, right? When I take 100 from here, I've got 600. I still have the 30 with the 12. 30 plus the 10 is 40, plus 2 more is 42. So 600 plus 42 is 642, right? Then we also have mental math. Mental math is different for everybody depending on what numbers are friendly in your head. So putting these things together, some people start with 300 and 200, and then they know 50 and 80. It's a lot like expanded form, just depending on the problem. So mental math is where you play with the numbers in your head to put them together. We'll look at some examples of that in a minute. Let's look at some subtraction. When we subtract, a lot of things look the same, but there's some differences. So let's start with 312 minus 175, right? So starting with the algorithm, again, it's a little bit more challenging, right? Subtraction always feels a little bit more uncomfortable, but we can break up our parts here, our place value chart, and I'm always going to start where? Yes, in the ones. So 2 take away 5. If I have 2, I can't take away 5, right? I still have enough. I have my top number is bigger. I just have to go get some 10s to help out my ones. So if I take this 10, now I have 0 10s. But he comes over to the ones and gets with the 2 that were already there, which makes 12 ones. 12 take away 5 is 7. Now I have 0 10s and I have to take away 7 10s. Can't do that, right? I have to go to the hundreds and break some up. It's called rearranging or regrouping. So these 2 hundreds, but the other 100 came over here as 10 sticks of 10. So now 10 sticks of 10, take away 7 sticks of 10, leaves me 3 10s. 200, take away 100, leaves me 100. So there's my answer. I could also use a pictorial model for this, right? In a pictorial model with subtraction, the difference is I'm only starting with the top number. I'm only starting with the whole, right? And I'm taking away a part. So I'm only going to draw my first number, 312, because that's what I have. Let's say this is $312. I spent $175. I've got to take that part out, right? So again, I'm going to start in the ones. I need to take away 5 ones. I don't have 5 ones, do I? So I'm going to come over here to the 10s, break him up, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I know that's kind of hard to see on here, huh? Need to make them a bit bigger. Now I can take away my 5 ones. 1, 2, 3, 4, 5. That leaves me with 7. Now I don't have any 10s, right? But I have to take away 7 10s. So this 100 is going to come over and be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 10 sticks of 10, right? Now I can take away 7 of them. 5, 6, 7. That leaves me with 3 10s, or 30. Now I have 200s, and I have to take away 1, and I only have 100 left. 100 plus 30 plus 7 is equal to 137. Another good strategy for subtraction is a number line, right? A number line is helpful for finding the difference between 2 numbers, and that's what subtraction is. It's finding the difference between 2 numbers. So on my number line, right, I'm going to put my bigger number over here, and I'm going to put my smaller number here, and I'm going to find the difference. Now, the thing about a number line is it looks different for everybody based on friendly numbers in your head. I always want to get to the friendliest number possible. So I could hop 5 and get to 180, but I also know that quarters help me a lot thinking about when numbers end with 25, 50, 75. So I know that 75 plus 25 is going to get me to 200 because 75 and 25 make another 100. Right? Well, now I know that 200 to 300, that's a jump of 100. And then all I have left here is the 12, right? So 100 plus 25 plus 12. So when I put that together, hopefully not too low here. Well, I'm going to take the 10 and the 2. 25 and 10 is 35, plus the 2 more, 36, 37. 137. That's another strategy, right? Okay, now let's talk about story problems real quick. When you are doing a story problem, before you can do any of this, the first thing that you have to do, right, is decide what kind of problem it is. When you're doing a story problem, you might be joining or combining, right, which means we're putting different things together. You might be separating, right, which means we're taking things apart, or we might be comparing, right? Those are all different kinds of story problems. I've made a few of each of those this week for you to practice, all right? Remember that there's different strategies to help you set up those problems too. Let's think about this one. Grandma baked 350 cookies for the party. At the end of the party, there were 125 cookies left. So, how many cookies got eaten? Let's think about what we know and what's happening. So, Grandma baked 350 cookies. At the end of the party, there were 125 left. What happened to some of the cookies? They got eaten, right? So we have to think about all the cookies and some going away. So this is a separating problem. So if Grandma baked 350, everybody ate some, and now there's only 125 left. We have to figure out the part that the people ate. But I can't start with 350 and take away some number and get to here, right? So I've got to think about how this problem relates to a part whole. Well, if I think about the whole, that would mean all the cookies. I know that. That's 350. If I think about the part that got eaten, I don't know that part. That's my question mark, right? Which is my box. I know what's left, 125, right? So I know that if I know the whole, I can take away one part and get the other part. So I don't have to take away something I don't know to get this. I can take away this and get the missing part. So if I take all the cookies and I take away the part that's left, it's going to leave me the part that the people ate, right? And again, I can solve this with the algorithm, pictorial model, number line, mental math, right? This is a good mental math one. I know that 300 take away 100 is 200. And 50 take away 25 is 25 because quarters really help me with those numbers. So 225 cookies must have gotten eaten at the party, right? All right, this week you're going to be solving some problems and playing some games to help you solve some problems. Remember all the strategies that we've learned and the ways that help you be more efficient problem solvers. I know pictorial model is pretty comfortable, okay, and it's okay sometimes, but I want you to try to branch out too and try some of our other models. Try a number line, try some mental math, try some expanded form, maybe even the algorithm, right? That's probably what your parents want you to do. That's how they know. That's how we learned when we were kids. And if we understand it, it can be more efficient. But we also want to try all these ways to show that mathematicians can solve problems in more than one way. So happy solving this week. Have a great week, and I'll see you later.